All right, in this video, we're going to work with multiplication of fractions. To multiply a fraction, you're going to multiply the numerator times the numerator and the denominator times the denominator. It's just as simple as that. So 8 times 6 and 7 times 5. 8 times 6 is 48. Excuse me, 7 times 5 is 35. Then you're always going to check your answer to see if it can be in lowest terms. Will anything go into 48 and into 35? No. So this is our final answer. Even though it's an improper fraction, unless our directions tell us to write it as a mixed number, we're going to leave it as an improper fraction. Next one, we have 3 over 17 times 17 over 8. And we're going to do what we call canceling if we've got the same number on bottom that we have on top, and it doesn't have to be a numerator denominator in one fraction as long as it's a numerator and a denominator. I can cancel. I can go across the multiplication sign. Multiplication is the only operation in fractions that you can cancel. Okay, and then, so when I go 17 into 17 is 1, 17 into 17 is 1. I'm doing 3 times 1, which gives me 3. 1 times 8 is 8. The majority of the time, this will be in lowest terms because you've canceled within your fraction or within your problem. But always double check and make sure that your answer is in lowest terms. Now let's look at the last one. In this row, we have 9 over 20 times the whole number 8. I'm going to put 8 over 1. And then I'm going to look and see if I can reduce anything within my fraction. Just like we canceled the 17s, I'm going to look and see, 9 is odd, so it doesn't go into 20, and it doesn't go, well, then 8's on top too, so can't cancel across the top or across the bottom. It has to be from top to bottom. So I'm going to look what will go into 8, what will go into 20. And they're both even, so I know 2 goes. But I also know that 4 goes into 8, so I'm basically dividing 8 by 4. And 4 goes into 20, so I'm going to divide 20 by 4. And when I do that, 8 divided by 4 is 2. 20 divided by 4 is 5. And so that's reduced my fraction already. Excuse me, already. So I have 9 over 5 times 2 over 1. And I always double check, is there anything here that will reduce? And in this case, no. So I'm going to multiply straight across. 9 times 2 gives me 18. 5 times 1 is 5. And then check your answer. Will anything go into 18 that goes into 5? And no, because we've already canceled everything we could. Then I'm going to look at the next row. Of means to multiply. So I'm doing 1/7 times 1/5. And I'm going to look, can I cancel anything? No, because basically both numbers on top are 1s. So I'm going to multiply straight across. 1 times 1 is 1. 7 times 5 is 35. Always double check, but 1 over 35 is not going to reduce. Next one on this row, 1/3 of 27 over 5. Again, of means to multiply. So I've got 1/3 times 27 over 5. And I can look at it real quick, see that I've got a 3 in the denominator and a 27 in the numerator, and I know that 3 goes into 27. So 3 goes into 3 1 time. 3 goes into 27 9 times. And that leaves me multiplying 1 times 9, and I get 9. 1 times 5, and I get 5. So that's my fraction. I make sure it doesn't reduce. And I'm good. All right, the next fraction is 11 over 22 times 51 over 77. Now, I know 11 will go into 22 and 11 will go into 77, but I can only cancel one of them. And I'm going to take 11 into 11 one time, and I'm going to do the 77 because it's a larger number. So 11 goes into 77 7 times. And then I'm going to check, is 51 divisible by 7? And it's not, and 51 is not divisible by 2. So I'm going to then multiply 1 times 51, 51, 22 times 7, and I'm going to get 154. So 7 times 2 is 14, carry my 1, 7 times 2 is 14, 1 is 15. Okay, so I have 55 over 154, and it doesn't reduce. Now I'm going to look at multiplication of 3 fractions, and I'm going to show you a little bit different process, and then I'm also going to show you canceling. But if I look at this first one, some people understand, or some people can get this better than they can get the canceling. So we're going to take this first one and we're going to break it down into prime numbers. So I'm going to take each one of my numerators and each one of my denominators, and I'm going to break it down to prime numbers. So 87 if I go over here, 87, and I have to sometimes go through, I know it's even, won't go into it, but 3 goes into it 29 times, and 3 and 29 are both prime. So I got 3 times 29, and I'm just going to go straight across the top. 66 is 6 and 11, and then 6 is 2 and 3, so that gives me 2, 3, and 11. 14 is 2 and 7, and then I'm going to come across the denominator. 33 is 3 and 11, 10 is 2 and 5, and 58 is even, so I'm going to divide it by 2. So when I break 58 down, I get 2 and 29. So 2 and 29. Now this is an easy thing about primes because we can see it. Everything's down to prime numbers, nothing reduces any further. So for every number I have on top that matches a number on bottom, I can cancel. So I have a 3 on top, we'll cancel 1 3 on bottom. I have a 29 on top that will cancel the 29 on bottom. I have a 2 on top that cancels a 2 on bottom. I have a 3 on top, but I don't have another 3 on bottom. I have 11 on top that'll cancel 11 on bottom. I have a 2 on top that'll cancel this 2 on bottom. And I have a 7 on top that doesn't cancel anything else on the bottom. So then I am left with, on top, and I'm just going to kind of circle so we don't lose them, a 3 and a 7, and then I'm left with a 5 on the bottom. Oops. So that gives me 3 times 7 over 5. 3 times 7 is 21 over 5. Sometimes this is easier if you break it all down to primes and you're not multiplying straight across and getting a huge number and trying to reduce the huge number. And this is also easier than trying to figure out what cancels what goes into what, and how it cancels. And you can do a combination of both. You can do just the canceling, which I'm going to do in this next multiplying 3 fractions. So I notice, I'm going to change my color back again. I have a 20 on top, cancels the 20 on bottom. Easy enough, because they're the same. And then I have a 10 and a 100. 10 goes into 10 one time. 10 goes into 100 10 times. And that leaves me with 12 and 15. 15 is 3 and 5, and 12 is 3 and 4. So 3 goes into both of them. This is 4. This is 3. No, not 3. Excuse me. 3 goes into 15 5 times. And then I'm going to multiply straight across. 1 times 5 times 1 gives me 5. 4 times 10 gives me 40. Well, notice I didn't catch everything because 5 and 40 will reduce. I can divide them both by 5. They're both divisible by 5. So 5 divided by 5 is 1. 40 divided by 5 is 8. So my final answer is 1/8. Okay, so I canceled on one. I worked prime numbers and canceling on the other. And then we have one more. And I'll probably kind of do a mixture of both on this. I know I can look at 10 and 90 and say, okay, 10 goes into 10 one time, 10 goes into 90 9 times. And I don't see anything else that just jumps out at me except for maybe 23 and 46. Because 2 times 23 gives me 46. So I know 23 goes into 23 one time. 23 will go into 46 2 times. So then I'm going to have 40 times 2 over 9 times 1. And if I take them all the way down to primes, 40 is 5 times 8. 8 is 2 times 4, and then that 4 is 2 times 2. So 1, 2, 3 2s and a 5. And a 5, and then I've got this other 2. 9 is 3 times 3, then times my 1. And I'm doing this just to make sure I'm not missing anything that will cancel. And it doesn't. So then I can multiply 40 times 2, and I can get 80 over 9. And I know that 80 over 9 does not reduce now. So you can do a mixture of both. Or you can do one or the other. So that's all for this video.